Good afternoon, everyone. It's my pleasure to have the opportunity to speak with you today. The title of this talk is around lessons learned from production deployments of network functions virtualization infrastructure within a number of carrier operators throughout Europe. And the second part of today's talk will really be to share with you a little bit about our view, when I say our, VMware's view, on some of the major trends that we see within the industry as it pertains or relates to network functions virtualization. So firstly, I'd like to apologize. Unfortunately, my Polish is not up to scratch, and therefore I have to deliver this in English today. But I will try and talk slowly because I do also acknowledge I have quite a strong Glaswegian Scottish accent. So please forgive me for that. And if I do talk too quickly, I will slow down. So in terms of the lessons that I would like to share with you from our production deployments today, they start from a lesson whereby we've understood that there is a need to adopt a common platform when it comes to a network functions virtualization infrastructure. And we'll share some of the reasons behind why we believe that is the correct approach, and indeed has been the approach that some of our carrier operators in EMEA have adopted today with some success. The second is really around taking a modular approach. I think I started out with network functions virtualization about 4 years ago, and I look at the market and the industry, and we realize that it's still an emerging area for many of our operator customers. Indeed, many are still just going into production today. And if we think about taking a modular approach, it allows us to insert and adopt new technologies from new vendors, as and when those technologies mature and are ready to be deployed. Indeed, in some cases, around areas such as service orchestration, there may be new entrants to this market, new startups, incumbents who have to adapt and evolve and change. As we look at those companies, ideally, if we have a modular approach, then we can insert their technologies in conjunction with the platforms you deploy across the stack. From a third perspective, one of the key things we've learned is that when we have a conversation about the strategic direction, and clearly network functions virtualization is a strategic choice that you as an operator may make, then we have to look to maintain open interfaces between those components. Because if you wish to take a modular approach, then clearly those interfaces need to be well defined, and indeed they are set out by the European Telecommunications Standards Institute with their NFV reference architecture. But secondly, those interfaces need to be open so that we can insert and integrate those other components that we mentioned earlier. Now, we've talked a little bit about technology, but clearly one of the biggest challenges we're going to see is not actually a technology issue, but is the organizational change that needs to occur in order to satisfy network functions virtualization requirements. Today, when I speak with many of our customers, they may be familiar and comfortable with mobile terminology, with fixed line terminology, but when you mention around hypervisors, a look of confusion comes down. And therefore, one of the things we have to do is look at how do we embrace that cultural change that has to happen within an organization in order for them to be able to successfully adopt and adapt to take this technology further. And lastly, we'll share some ideas about how did these customers get started? Which use cases did they adopt first? Where have they been successful? And how have they taken those use cases into production? And some of these use cases are in production today. So if we think about the business case, the requirement about why we needed network function virtualization in the first place, then today we still see dark pools of capacity within our data center. Pools of capacity that cannot be unlocked because effectively you've tied the service or the function to a specific hardware component. And one of the things we see is that as you have to react and adapt to subscriber demands, subscriber growth, bandwidth increases, then what happens is as an organization, as a business, you sink your investment into hardware which effectively cannot be realized or the fancy phrase amortized until such times as those customers accept and adopt and use that capacity you've invested in. So clearly we have pools of resource that are unused, but conversely, on the negative side, we also run the risk of not delivering that capability or that capacity just in time. And what ends up happening is that you don't have enough capacity to service those customers. When that happens, that can impact things like customer churn, and it can significantly impact some of your key performance indicators around customer satisfaction. So if we look at the options that are available then when you make that strategic choice to adopt network functions virtualization, then broadly speaking, there are 3 architectural choices that are available to you. The first is we have seen virtualized network function vendors come to market and say, well, we could deploy our virtualized network function, or VNF, on top of a hypervisor. And that hypervisor runs on a piece of hardware. Now, the issue with that approach is that for many years, VMware as a company has been selling cloud software, and I can assure you that if you buy a hypervisor, you've not bought a cloud. What you've bought is a hypervisor. To be clear, the hypervisor is a means to an end to virtualize a server, but it does not give you the ability to orchestrate and automate that infrastructure. So from that perspective, when we see this appliance approach whereby we see a dedicated virtualized network function run on top of a hypervisor, then clearly we do not adhere or meet the aspirational goals of building a telco cloud on which we can run any virtualized network function anywhere within our telco cloud on top of any hardware. So the second approach that we see in the marketplace today is when a vendor or a virtualized network function vendor comes to the market and says, we understand the problem. We understand that we wish to provide a cloud platform in which we can run our virtualized network functions. But what they do is they provide an optimized stack, which effectively they run their VNFs on. Now, that might work well for the first VNF. So if you take from vendor A VNF, they may have several VNFs in their organization, but the reality is what happens when vendor B comes in with their virtualized network function? Are they happy to run that VNF on another vendor's optimized stack? And indeed, in some cases, they're incompatible. Some vendors might use, for example, a vSphere or ESXi hypervisor to support their VNFs. Another vendor might only support their infrastructure with vSphere running on top of a specific hardware platform that might not be supported by that first NFVI platform vendor. So the problem is when we look at this custom stack, we still have the problem of building out siloed infrastructures because we build optimized stacks for the VNFs. Now, the third model which we believe in, and I think we are beginning to see the industry begin to reflect some of these options, is that we build effectively what we call a common platform. Now, the common platform effectively is a platform that the operator builds. So, for example, if you're a communications service provider that provides mobile services or fixed line services, you build that platform, and we can provide you the components to build that platform. But here's the benefit, is that you are now in control of that platform, and those virtualized network function vendors have to build their VNF and run their VNF on your platform. So this means that vendor A and vendor B that we described before, now they have to compete to be on your platform because now you have choice of vendor. You can build a platform that uses your selection of hardware, that uses your selection of software, but now they can run that VNF. But the thing is, they will ask from you certain guarantees. One is service level agreements about how much CPU, memory, disk I/O, network I/O, etc. can be achieved. How do they get the affinity rules to make sure that their virtualized network functions runs with the performance metrics and characteristics that they expect? So from your perspective or an operator's perspective, you have to be able to provide those guarantees. And indeed, as we talk through today's talk, one of the things we will share with you is how you can provide those guarantees to those VNF vendors. Now, as we move forward, one of the things we'll do is we'll refer to a couple of use cases, but I wanted to give you a sample of just where we are today. So I wanted to point out one example would be Ooredoo, who are an operator based in the Middle East. And Ooredoo were quite interesting because one of the things they did is they stated that they wanted to deploy their virtualized IMS or IP multimedia subsystem running on top of a VMware platform. Now, when they built that platform, it took them 2 months to go through the research and development project, but now they have the ability to roll out on demand a virtualized IMS within 2.5 hours. And that is a fundamental change now to the way that they build out and deliver services within their organization. I think also with regards to this deployment, 3.5 hours, I do stand corrected. One of the points on this is that they use their network virtualization platform, VMware NSX, to effectively deliver the SDN infrastructure that allows them now to flexibly place any workload anywhere within their data center. The second example I make reference today is Vodafone. Vodafone and EMEA have built a common platform based on VMware's technology. And again, you can see here that it's not so much the VMware decision, but it's by making that decision to own and manage our own platform is what gave them the strategic differentiator in terms of now being able to go to the marketplace and say, if you want to work with Vodafone, then your VNF has to run on our platform. And this now gives them that freedom of choice and freedom of selection across their technology vendor space. The last point, though, which we as a company, as VMware, are acutely aware of, is that whilst I think we would obviously agree with the first statement, which is that VMware today have production deployments of NFV for actually several years in the case of Vodafone. But one of the things we are very aware is that there is this open source aspect to all deployments that we see today, and whether that be around supporting open source cloud management systems such as Openstack, or whether it be for providing open APIs for the consumption of service orchestration platforms, then one of the things we are aware of is that clearly this over time is going to become a more contributing factor or significant factor in the choice of technology. And one of the things I'd like to share with you today is just how VMware's approach about how we integrate into that open source community and how you can take advantage of some of the contributions that we've made. So in terms of the business drivers, just to kind of conclude on those, I mean, the key point is that if we look at a virtualized evolved packet core deployment, then one of the things we've done is done a case study with Affirmed networks. Affirmed are slightly unusual in the fact that they didn't come from a hardware world, but indeed they built their platform to run on a cloud infrastructure. And if we think about their background and history, one of the things they've done is they've provided the ability to deploy both faster and at a lower cost point a virtualized evolved packet core for a mobile operator. And the way they've achieved this is they've used the cloud economics, they've used the cloud infrastructure as a way to build out a scalable virtualized evolved packet core solution that is not tied to the physical hardware as it was for maybe some of the other organizations and incumbents in our market. Now, these numbers are based over a 5-year estimate, and again, it gives you an indication about over-provisioning, about spares, about having to manage service contracts across all of those different vendors. And clearly, if you now move to a virtualized network model, then of course, at that point, you can now amortize those in a far more efficient way by using custom or commercially off-the-shelf hardware. The other point is noted, I mean, Ooredoo was an example where we thought, well, 2 months is a fantastic reflection on their capability to execute. Affirmed, they reckoned about 6 months is the time to actually deploy and get a new virtualized evolved packet core up and running. But if you contrast that with the appliance-based solution we talked before, clearly there's a significant difference in the time to market and time to revenue for those services. But the key point that is brought out by Affirmed and by others is that for many operators, they're still in a position whereby they're not certain yet when and how they will adopt network functions virtualization. But the key point is that if you wait to adopt network functions virtualization, and it might be because you maybe don't believe the technology is right to go into production, and hopefully like some Vodafone or Ooredoo and other vendors or other operators we're working with has demonstrated to you, is the fact that if you wait for every year, it will cost you twice as much in terms of the expense of operating in the old model. And again, we have a report that will give you some of the facts and figures behind how we reach these conclusions. But as we kind of move forward then about how we build out the services, then the first point to note is that today we see this siloed model whereby we see these customized stacks and people build out their virtualization infrastructure to support those service applications. But of course, each one of these silo stack comes with its own training courses, their own requirements for having separate operations, and clearly that puts a burden onto you as an organization about how you support that infrastructure. So one of the things we believe is that having this common platform basically provides out a horizontal scale-out model to support any VNF from any VNF vendor in a multi-tenanted cloud. But of course now, because we use this horizontal NFV cloud platform, because now you have the ability to take advantage of all the hardware compatibility lists, all of the available infrastructure that's out there, then we can have a common pool of resources on which we run that NFV platform. So if you've chosen to go with a specific vendor for your server compute nodes, then clearly that can be supported now over the top. You're not dictated by the VNF vendor. And of course, your people, process, and procedures also apply. So it's lower cost, but also gives you faster time to revenue because now you've got a competitive advantage and competitive differentiation by creating new services because you've got flexibility of product selection that maybe you wouldn't have had if you were prescribed or defined by a single vendor. So the last point before we move on to the more technical aspects of the solution is that clearly NFV and network functions virtualization is going to drive a change in the organization. And this is probably one of the biggest barriers to adoption of the technology today. So we see emerging roles occur in the organization. And I would ask maybe if you're in an operator, in a communications service provider today, is to looking at yourself and say, where do I sit within these types of roles? So one example might be from a platform operations side. That might be the team that understands and knows, for example, how to build an MPLS infrastructure, that knows how to build, for example, customer premise equipment solutions. Maybe in a mobile space, they understand the RAN, they understand what the evolved packet core is, and they understand the IMS, they understand the GI-LAN, they understand all of these capabilities. They've been doing this probably for many, many years. But the question is, are they comfortable to be able to explain and articulate the requirements to, for example, the cloud infrastructure owner? Somebody that owns and operates a cloud platform. Somebody that understands hypervisors, they understand the storage world, they understand the virtualized networking world. They have the ability to pull all these parts together and operationalize this so that they can fault find and troubleshoot problems as and when they should occur. But clearly, these cloud owners also have to be able to understand the language and the vocabulary of the mobile or fixed line platform operations team because they have to be able to react and adapt to their needs. And lastly, we have the service architects who have to be aware of the capabilities within the network function virtualization space, who have to be able to understand the VNF marketplace and bring those new services based in a virtualized form factor and be able to deliver them in an operational manner. So one of the things we've announced is our VMware Vcloud for NFV platform, and this really is a common platform. And we believe that the reason why it's been successful in production to date is firstly, culturally, we're not competitive to any of the VNF vendors. So for example, you'll see some names around the room of companies who, for example, create virtualized network functions, and VMware does not compete with those vendors. So by having a network functions virtualization infrastructure provided by an organization or a vendor such as VMware means that you've now got freedom or flexibility of choice in those VNFs. And those VNFs themselves, we support today 40 virtualized network functions from 30 different VNF vendors. In most cases, they're happy to run on a VMware platform because we're not competitive to their business. But secondly, one of the things we've done is we've built it around the European Telecommunications Standards Institute framework. And you'll see, and we will try and explain to you, where we see VMware fit within that architecture. Now, clearly, VMware has been building multi-tenanted clouds for many years. We've had vCloud Director in our portfolio, and clearly, we've been focused at the enterprise IT marketplace. And we're the first to recognize that the requirements of the enterprise IT marketplace are very different from what we see within the communications service provider or telco market. But clearly, there's many overlaps given the fact that we're pulling the IT paradigm into the telco space. So that's the reason why we believe we're well placed to help support many of the requirements that we see today within the market. And one of the things we believe is that there is value to running one platform for both your service provider requirements as well as your IT requirements. Now, clearly, they might run in different resources, but having the operations expertise you may already have in your organization around VMware, and clearly with many hundred thousands of customers, it's very easy to find people with VMware experience. You can have them run and help assist that cloud operations team to make sure they can run those mission-critical services on top of a VMware platform. But we're also aware of the fact that we have to evolve to support open APIs, and clearly one of the things we wish to do is to support open APIs based on Openstack. And we'll talk about our route to Openstack support in a moment. So just to give you a flavor then of some of the aspects that we support in our platform, we work with, as I mentioned, 40 different VNFs from 30 different VNF providers. Just a selection of the names here of some of the vendors we support. But in terms of the use cases, they divide equally across fixed line networks as well as mobile networks. But clearly, when it comes to getting started, there are certain areas that are easier to virtualize than others. For example, in the signaling plane, we run off the box or off the shelf in terms of support, for example, the IMS core. We do support in the virtualized evolved packet core capability. We mentioned our firm just a few moments ago. Again, we have successful deployments in production running on top of a VMware platform. But clearly, as you move towards things like the radio access network, there are further demands in terms of latency and jitter. And whilst technically we can probably express how we're going to deliver and achieve the low latency and jitter that those requirements have, clearly that's probably the hardest place to start. So if you wanted a recommendation, for example, the IMS would be a good place to start in your mobile networks. And for the fixed line infrastructure, of course, we have successful references for virtual customer premise equipment. And we'll close off today's talk with a very brief demo about an example whereby we've used Cyan as an orchestration platform along with a company called Versa Networks to demonstrate a virtualized network function. So in terms of the architecture and the strategy that we've worked with customers is that we've taken a modular approach. So today we start and say, well, look, if you want to build a network functions virtualization infrastructure, then you can start and consume what we call the Vcloud API. And clearly the interfaces are the demarcation between both the service orchestration platform, the VNF management platform, into the infrastructure layer. And today, all of those vendors we mentioned write to those Vcloud APIs. But obviously, as we move towards an Openstack API as consumption, the bottom part of the picture remains the same, but what we see is the Openstack APIs, so your Nova, your Neutron APIs, can then be consumed to instantiate and deploy those applications. And we'll talk a little bit about how we provide the Openstack APIs running on top of effectively a VMware infrastructure. So you can take the best of both worlds. You can take the best-in-class hypervisor platform with all the features about fault tolerance, high availability, and combine that with the open APIs you find in OpenStack. Now, clearly, the reason why today we're not deploying with OpenStack, generally speaking, is that we have many capabilities that you will see in the Vcloud for NFV platform that don't exist in the OpenStack world, specifically around resource guarantees. And we see a lot of progression towards the likes of the OP NFV community and that project to basically drive the requirements into the open source communities to provide those capabilities. But frankly speaking, they're not there today. So today, for most operators, as we mentioned earlier, they are going with a VMware Vcloud NFV platform to be able to satisfy and address those requirements. So then drilling down a little bit then on the ETSI framework, basically the VMware solution breaks into three components. First of all is the NFVI, so the bit in blue. Here we satisfy the requirements for virtualized compute, vSphere and ESXi, of course. For storage, we have a software-defined storage capability called vSAN. And then for software-defined networking, we have a platform called VMware NSX. Of course, this can run on top of the broadest and most expansive hardware compatibility list in the industry. But clearly, we have to then run infrastructure, and I apologize, it's hard to see on this projector, so I will try and read out basically what it says. But that includes things like vCloud Director, vCenter, coupled with our network functions virtualization and operations solution, which includes things like vRealize operations and our log insight platforms. Now, those present interfaces up into the higher level components, so the VNF Manager, Orchestrator, and VNFs. VMware today does not provide those components, and indeed, we provide open interfaces or well-defined interfaces into those solutions. And again, we will explain some examples in a moment. So as we break down then each one of those blocks, today when we deploy a NFVI, then what happens is we actually deploy across multiple data centers a solution that has networking provided at the external layer. But then what we do is we provide multiple redundant components that allow us to satisfy requirements and requests from higher level solutions. So for example, when your service orchestrator wishes to instantiate a service, it can make requirements over a highly available fault-tolerant set of cells. Each one is independent, can act independently of each other, with shared and highly available databases in the back end and message queues to make sure that we have transaction reliability so that we can understand what we provision down into the virtualized infrastructure below. As we build out this design, the key point here is the API. So the API is what the VNFs and the VNF managers will consume. As we move into this picture, what we have is the operator view. So to explain what we see, we have basically a set of resources that can be carved out by the operator. So remember the point earlier on about providing service level guarantees. You can provide a set of resources with dedicated memory, even down to the number of clock cycles. You can provide dedicated CPU and dedicated storage and networking. And then what we can do is carve out these resources and provide them and allow them to be consumed by tenants. In this case, we call them organizational virtual data centers. But really, this is just a VNF vendor. So for example, the VNF vendor X can have his set of resources, VNF vendor Y can have his set of resources, and these resources can be consumed by his virtualized network function. And this allows them to have this self-service model where they can provision their application in a fully multi-tenanted fashion with complete isolation, both from a management perspective, but also from an infrastructure perspective as well. And here, for example, you can see the various vendors now consuming over those APIs into what we call our Vcloud Director platform. And that can be done via an API, or it can be driven manually as well. From a networking domain, we keep separation again all the way through. So here, for example, you've got your MPLS network connected to what we call an Edge Services Gateway node. We provide and support dynamic routing, so we can advertise prefixes that are created within those virtualized data centers. We can then service and provide separation all the way down so that we have effectively self-service networking for those vendors. So one example in many use cases we see is whereby you have a hardware manufacturer who's built, for example, a platform today, and maybe they have a backplane for connectivity between blades on their platform, and they've ported that maybe to a virtualized form factor. Then one of the things they can do is they can actually pull all of those backplane connections, virtualize them as logical networks, and then they can apply them as logical networks within their organization. And they can have freedom of choice about creating any arbitrary topology they wish within that virtualized network function. And of course, it's not just about the infrastructure servicing it, but how you operate it, run and maintain it as well. And for that, we've built a holistic set of tools to provide things like disaster recovery, operations dashboards, log aggregation, log consolidation. And again, this can be done in a fully highly available manner so that if we have a failure of a site, we can then continue and have continuous availability and operation of your application across both sites. Now, we mentioned clearly to date, this is all based on VMware technology, but one of the things we want to emphasize is the open source credentials, because we do understand and acknowledge the fact that we do need to satisfy that requirement, and specifically it's for open APIs, and their Openstack tends to be the way the industry is moving and evolving towards. And clearly, VMware, we're open to being open. We want to help satisfy many of those requirements, and indeed, not only have we announced our participation in the NFV community, so that we will contribute some of our ideas about where we need requirements to be contributed back to the Openstack and open source communities, but also some of our community involvement as well. So for example, VMware created Nicira created the Open vSwitch project. That also led and the founder created OpenFlow as a technology, and we've contributed that back to the open source community so they can then adopt and use those technologies as they see fit. So in order to satisfy this, one of the things we see is a question that sometimes comes up about how do you build an OpenStack model that can take advantage, therefore, of a VMware-based infrastructure platform. And today, for those of you who have tried to build OpenStack environments, you will know it's a very complex and challenging thing to do. So one of the things we have done is we've created an OpenStack distribution called VMware Integrated OpenStack. It's something that's available to you free of charge and can be deployed with support from VMware at a charge. And basically what happens is you basically get to provide a virtual appliance that can then deploy a highly available, resilient OpenStack architecture. So this includes resilience and availability across all aspects of your OpenStack deployment, whether it be controllers, whether it be the databases, whether it be the message queues. And for those of you who have ever built OpenStack, you'll know how complex it is to build this. Now, the fact that you can take a virtual appliance and deploy that virtual appliance and have all of these components built for you means that it's the fastest and easiest and simplest way to deliver an OpenStack environment. Plus, we also provide day two operations using the same tool set and tool chain as we showed you for your virtualized network infrastructure. So clearly, as this modular approach, therefore, takes us to a point whereby now we can satisfy and support multiple service orchestration platforms at a higher level. So today we support and have worked and collaborated either on proof of concepts or on production with those service orchestrators. Just some are shown on the screen. But one of the things I wanted to close today on was basically a quick demo to show you just how we can use these interfaces to deploy and build a service. So what we're going to show you is the The virtualization layer is going to be based on the Vcloud for NFV platform we've described. We'll then show you basically an orchestration platform at the top from a company called Cyan, and we'll use their orchestration solution to provision a virtualized network function from a company called Versa Networks, who provide a virtual customer premise equipment solution. So the way that it works is that we have our service orchestrator make those open API calls into the virtualization platform to instantiate a virtualized network function. And here, for example, we might have multiple customers. Customer A might have a set of services, for example, network address translation, firewall, content delivery networking. And customer B might have a different set of services that get instantiated for him on the same infrastructure. And we'll provide resource guarantees and separation between them. So, apologies, a little bit out of focus, but basically what you see here is Planet Orchestrate is the Cyan platform. And what we're going to do is we're basically going to log into this platform, the solution. We're then going to instantiate our virtualized network function. So you will see here we've got a various number of services that we can choose from. We'll select all products in this case, and we'll search for an appliance that matches the Versa virtualized customer premise equipment solution. So we'll create a new Versa appliance, so the appliance will get deployed. This appliance then gets instantiated and attached to an IP VPN services. So this way we're going to couple it to the VPN that already exists. There are a number of options across the top. So we could add, for example, firewall policy. We could do things like static NAT, dynamic NAT, port address translation, etc., port forwarding. All of these services can be added on demand to this VPN. And as we build out and deploy this solution, what we'll show in real time is effectively not only the VPN service, but all of the components then that make up the service in the virtualized customer premise equipment solution. So each of these boxes represents the virtual firewall, the virtual router, the virtual appliance that gets deployed. Now, once the service is active, we then have the ability to go back in, check that the solution is up and running. But then if we drill down into the Versa solution, we'll be able to then see, for example, in the Versa director, the health and the state of the environment. So we'll be able to see, for example, here, that we've actually provisioned that virtual customer premise equipment. We'll be able to go in and analyze metrics. We'll see, for example, the services that are deployed on that solution. We can then select additional capabilities, whether it be carrier-grade NAT, VPN, or application delivery controllers. We can then check our firewall policies and see what firewall policies are pushed into this virtual customer premise equipment. And all of this is done and instantiated using the underlying APIs that we talked about earlier. So as the integrations, whether it be using the open interfaces between the service orchestrator and the VNF manager, or in this case, using those same APIs to provision this infrastructure down into the Vcloud Director platform. And what you will see as this demo kind of closes is effectively the appliances are now deployed in this multi-tenanted cloud running on the VMware Vcloud NFVI. So I just wanted to kind of close then, in terms of experiences then, people are running NFV in production today successfully, and they have been doing for some time. The common experience, I guess, one of the things is that you tend to find is you see a lot of information out there about people who have deployed a proof of concept with one virtualized network function from one vendor, and they call that success. And for sure, that is a success in some ways. But the reality is a true common platform means you've got a shared experience running virtualized network functions from different vendors on a common platform to get the economy of scale and to be able to get the operational simplicity that you hope to achieve with virtualized network functions. The business alignment, one of the things we do see a challenge is you have to adapt your organization to change. Clearly, if you put all of the case in building your common platform behind the first VNF, then clearly that's going to be a high cost. But if you break down that cost across multiple virtualized network functions, then the economies of scale will allow you to achieve the cost metrics that we described at the beginning of this presentation. And lastly, I think it does take time to adapt the organization and the cultural change that is required to be successful to deploy network functions virtualization. And indeed, that's one of the requirements we see. So just to kind of close then, I think today, one of the things we are doing is we will be going to Barcelona for VMworld. If any of you do have the opportunity to come and see, we will be hosting our service provider customers. You can come and speak to those who are both live and those who are planning to go live with VMware and share further experience as well. And we welcome any of you to come to Barcelona to join us for that event. But at this time, I'm happy to take any questions if we've got a few moments.
We have 1 minute, so if anyone has a question.